Let's solve this complex question in 30 seconds. A body falls freely from rest under gravity. What is the ratio of the distances traveled by it in the first second, second, and third second of its motion? The standard textbook method is a massive time trap. You are taught to calculate the total distance at t equals 1, 2 and 3 using the formula s equals ut plus half gt squared and then manually subtract them. That takes way too long during an exam. Here is the 30-second hack, Galileo's law of odd numbers. For any body dropped from rest under constant acceleration, the distances covered in equal successive time intervals are always in the ratio of consecutive odd numbers. Watch the body fall on screen. In the first second, it covers distance 1x. In the second 3x. In the third second, 5x. The ratio is simply 1:3:5. That means option B is your correct answer. Spot the odd numbers, circle option B in 2 seconds and save precious time. Let's solve this complex question in 30 seconds. A car moving with a speed of v is stopped by applying brakes within a distance of x. If the same car were moving with a speed of 3v, what would be its new stopping distance under the same maximum braking force? The standard textbook method is a massive time trap. You are taught to set up v squared minus u squared equals 2as for the first case to find the retardation. Then plug that messy variable into a second equation for the new speed. That wastes valuable exam time. Here is the 30-second hack, the n squared rule. Since the final velocity is 0 and the braking force is constant, stopping distance is always directly proportional to the square of the initial speed. If you multiply the speed by a factor of n, the stopping distance is automatically multiplied by n squared. Let's look at the diagram. Car 1 goes at speed v and stops in distance x. Car 2 goes at a speed of 3v. Our multiplier n is 3. So the new stopping distance is 3 squared, which equals 9x. Option C is your correct answer. Spot the multiplier, square it, and immediately move to the next question. Let's solve this complex question in 30 seconds. A particle is moving with uniform acceleration along a straight line. If its velocity is v1 at point A and v2 at point B, what is its velocity exactly at the midpoint of A and B? The standard textbook method is a massive time trap. You are taught to use v squared minus u squared equals to 2as for the total distance to find the acceleration and then apply it all over again for the halfway point. That is a 3-minute algebra nightmare. Here is the 30-second hack, the RMS shortcut. For constant acceleration, the velocity at the exact midpoint of any displacement is simply the root mean square of the initial and final velocities. Look at the diagram. Point A has velocity v1, point B has velocity v2. At the exact midpoint, just square the velocities, add them, divide by 2 and take the square root. The answer matches option C perfectly. Memorize this root mean square rule and save 4 minutes on exam day. Solve this complex question in 30 seconds. The velocity of a particle moving in a straight line depends on its position x as v equals alpha times the square root of x. What is the acceleration? The standard textbook method is a calculus time trap. You are taught to use the chain rule, a equals v times dv by dx, leading to messy fractional derivatives that eat up your exam time and invite silly mistakes. Here is the 30-second kinematic comparison hack. Absolutely no calculus required. First, just square both sides of the given equation to get v squared equals alpha squared times x. Next, write the third equation of motion underneath it, v squared equals u squared plus 2ax. Since the initial velocity is 0, it simplifies to v squared equals 2ax. Now, just look at the two equations on the screen. By direct visual comparison, the coefficient of x must be identical. That means 2a exactly equals alpha squared. So a equals alpha squared over 2. Option B is your correct answer. Match the coefficients, skip the calculus and move on in 10 seconds. Let's solve this complex question in 30 seconds. Two cars are 150 kilometers apart and moving towards each other at 30 kilometers per hour and 20 kilometers per hour. A bird starts from one car and flies back and forth between them at 80 kilometers per hour until the cars meet. What is the total distance traveled by the bird? The standard textbook method is a massive time trap. You are tempted to track the bird's path, calculating an infinite geometric progression of smaller and smaller bounces. That takes 10 minutes and guarantees a panic attack under exam pressure. Here is the 30-second time decoupling trick. The complex path of the bird does not matter at all. Just find out how long it takes for the cars to crash. Time equals relative distance divided by relative velocity. That is 150 divided by the sum of 30 and 20. So the cars crash in exactly 3 hours. The bird is simply flying for 3 hours straight at 80 kilometers per hour. Distance equals speed multiplied by time. 80 times 3 is 240 kilometers. Option B is your correct answer. Find the crash time, multiply by the bird speed, skip the infinite series and you are done.